So in this video we are going to see about the insertion of doubly linked list. So that is different cases when you are doing the insertion in a doubly linked list, that is inserting the new node at the beginning, inserting the new node at the end, then inserting the new node after the given list, then inserting the new node before the given list. So these are the different cases. First we are going to see inserting the node at the beginning. So here the new node will be inserted at the beginning. So for example, this is the doubly linked list we have taken, and here we are going to do the insertion. Okay, so here we know this is a start node, right? So in this start node itself, so here we are not going to check any conditions. Directly what we will do, we will create the memory allocation for the node, and we will allocate the data. So for example, I'm giving the data as the 8. Then what we will do, we will change the address. So this here what will happen, this new node address will be saved here. Okay, new node address will be saved, and here in this particular part, next previous node, okay, here previous node address is saved here, and here it is null. Okay, so we will see the code. So this is the code for inserting the new node at the beginning of the doubly linked list. So here we are declaring one pointer variable, that is a new node. Okay, then we are declaring one variable num, it is for storing the data, and by using the scanf statement what we are doing, we are getting the value of the num. So for example, consider num value is equal to 6. Okay, so when you are executing this, what will happen, first it will print enter the data. So I'm giving the data as the 6, so this data will be stored in the variable num. Okay, the next, by using the malloc function, what we are doing, we are allocating the memory space for the new node. Okay, then next, so this is the new node. Okay, this is the new node, it contains 3 paths. Okay, then next what we are doing, new node tends to data is equal to num, we are allocating the data. So here we have taken the data as the 6, so we are allocating the data in the node. Then next what we are doing, start tends to previous is equal to new node. So this is the previous point, right? So start tends to previous. So in this particular part we are storing the address of this new node. So what will happen, the address of the new node is stored here. Address of the new node is stored here. The next what is given statement, new node tends to previous is equal to null. Okay, previous statement, new node tends to next is start, new node tends to next is a start. So here it contains address of this node, so it contains the address of this node, right? It contains the address of this node. And next, new node tends to previous is null, so this is the previous position, so it will be the null, so that is -1, or we can represent as a x. Then it will, then what we are doing, start is equal to new node. So now what happened, this start new node is a start node here. Okay, new node is a start node here. So I will repeat it again. Here first we are getting the value for the num. Then what we are doing, by using the malloc function, we are allocating the memory space. Okay, by using the malloc function, we are allocating the memory space for the new node. So this is considered, this is the new node, and we have taken the num value as a 6. Okay, we have taken num value as a 6. Then what we are doing, assigning the data to the new node. So we are assigning the data to the new node, that is new node tends to data is now. Then next, start tends to previous. So this is the start node and the previous is here. So here what we are doing, we are allocating the address of the new node. So this address, okay, new node address will be stored here. Okay, new node address will be stored here. Then next what we are doing, new node tends to next is equal to start. So new node tends to next, it contains address of this particular node. Okay, address of this node. Then new node tends to previous is null. So new node, this is the new node. Okay, this is the node previous, it will be the null. -1 or into. Then start is equal to now. Now we are making this new node as a start. Okay, so this is the code for the doubly linked list. And this is the algorithm. So as we are doing the insertion, we have to check the overflow condition. Then we are new node. We are creating the new node. Then we are allocating the memory space for the new node. And here code also, what we are doing, we are using the memory. By using the scanf statement, we are getting the value from the user. Okay. Then what we are doing, by using the malloc function, we are allocating the memory space for the new node. Then what we are doing, allocating the value for the new node, the same, allocating the value for the new node. Then what we are doing, first we are assigning new node tends to previous is equal to null. So this statement, new node tends to previous is equal to null. Then new node tends to next is start. So new node tends to next is start. Then start tends to previous is new node. Start tends to previous is new node. Then start is equal to new node. Start is equal to new node. Okay. So first we have to get the value, then we have to allocate the memory space for the new node, then we are assigning the value. Then what we are doing, for the start previous node, start previous, for the start previous, so this is the start previous, here we are allocating the memory space of the new node. Then what we are doing here, for the new node next, so this is the new node next, here we are allocating the memory space of the next node. And here next what we are doing, the new node previous is null, and we are making this as a start node. So this is about inserting the new node at the beginning.